Sampling distribution of the sample mean, example 1. Suppose that the mean IQ score for all Kentucky adults is 99.4 points with a standard deviation of 14.6 points. Consider a random sample of 200 Kentucky adults. The IQ score for each person is recorded and the mean is calculated. A. What does the sampling distribution for the mean IQ score for samples of 200 Kentucky adults look like? Give a complete description. B. What is the probability that the mean for this sample is over 101.5 points? To answer part A, we need to identify the center or mean, the variability or standard deviation, and the shape. Specifically, is the distribution like a normal curve? The mean is mu sub y bar equal to mu equals 99.4 points. Be sure to include units. The standard deviation of the mean is sigma sub y bar, which equals sigma divided by the square root of n, which equals 14.6 divided by the square root of 200, which calculates out to be 1.032376 points. Include units. Check the conditions to see if the curve is well approximated by a normal distribution. A random sample of Kentucky adults is selected and IQ scores are the measurements recorded, and n equal to 200 meets the at least 30 sample size requirement. All the conditions are met to treat the sampling distribution or the histogram of all possible y bar values like a normal curve. We say that y bar follows a normal distribution with mean 99.4 points and standard deviation 1.032376 points. For part B, you start with the value, then convert to a z-score and use table z. So the chance that the sample mean y bar is more than 101.5 is converted into the equivalent z-score question. The 99.4 points is the mean of the normal distribution, and the denominator of 1.032376 is the standard deviation. The result is that z is 2.03. What is the chance a randomly selected z-score is more than 2.03? See the sketch at the bottom of the handout. Table Z gives 0.9788 as the chance the z-score is less than 2.03. So 1 minus 0.9788, which equals 0.0212, is the chance the z-score is more than 2.03. In summary, the chance a random sample of 200 Kentucky adults will have a mean IQ score over 101.5 points is 0.0212, or 2.12%. Note this outcome would happen in roughly 1 out of 47 samples. That is just 1 divided by 0.0212, which is about 47. If an outcome has less than a 0.05 or 5% chance of occurring, that is considered unusual. Observing the outcome would be unlikely and hence cast doubt that the true population mean is the value given from mu. This particular outcome would have been considered unlikely if the true population mean mu is really 99.4 points.